Αποφάσεις.
Decisions, where we would be without them. Every action of ours, every second of our every day, from the simplest move to being present in Science Festival, and by the way, I'm very glad to be here, is the result of a conscious choice. Conscious or unconscious, philosophers claim that we are the result of our choices. Neuroscientists try to map the complex brain functions that lie behind our decisions. And the experts of computer science are wondering what is going wrong when we decide to concede part of the decisions made by ourselves to smart machines that think like us. With a rapid increase of AI applications, it becomes all the more evident that the use of AI entails many risks. It seems that the artificial intelligence systems are not as reliable as we would think compared to other systems of decision-making. Moreover, they have not a predictable behavior in changing environments. They require a huge volume of data and computational capacity in order to evolve. Well, they also reproduce the stereotypes that are included in the data that they are used in order to train the machines. In the Athens Science Festival, the professor of computer science at MIT, Konstantinos Daskalakis, will explain to us the reasons why artificial intelligence fails by analyzing the basis of machine learning. And he will show us how different ideas and the principles of mathematics and social sciences could potentially provide solutions to the challenges that have emerged, and also to the challenges that await us in the future. The discussion will be moderated by Marily Nika, Project Manager of Artificial Intelligence at Google.
Καλησπέρα ή καλημέρα σε όλους, ανάλογα με...
Good afternoon or good morning. My name is Marily Nika. I am in San Francisco. It's a great pleasure that I take part in Athens Science Festival. Yesterday I gave a presentation, but today I have the honor, both personal honor, but also the honor to represent Science Festival in order to moderate the presentation by Mr. Daskalakis. In case you don't know, Konstantinos Daskalakis is a professor of computer science in MIT, and his research focuses on social IT and its interaction with economics, statistics, and artificial intelligence. He has received many different prizes. Recently, in 2018, he received the top award, Panellina, which is awarded by the International Association of Mathematicians, along with the Fields Award for his contribution to the computer science field. So it is a great pleasure for me to moderate the discussion. We have two parts. In the first part, we will listen to the presentation given by Mr. Daskalakis, and in the second part, we will have a discussion around 20-25 minutes, during which he will reply to some of the questions you have submitted. I have also some questions to ask him, so without further ado, Konstantinos, thank you very much for being here. You have the floor. Good afternoon, everyone. Thank you very much, Marily. Thank you very much for the introduction. And also, I would like to thank the organizers of the Athens Science Festival for inviting me, but also I would like to thank all of you for being present. Humanity is now exiting from a huge crisis, and it was science that provided solutions to this crisis. But at the same time, we saw that there were certain disagreements among scientists on how this crisis should be dealt with. And these disagreements are connected to the topic of my presentation today, and this is how artificial intelligence fails. the machine learning and the computer science, how all these fail and what can we do about that. So to begin with, as we read in the mass media, artificial intelligence has evolved greatly during the last few years. On this slide, you can see a summary of the innovations that have been developed. They have to do with identifying the content of image, recognizing voice, the self-driving cars, machine translation, with the capacity of computers to beat champions in very difficult games, but also a new evolution, a new application, if you like, pertains to the capacity of computers to create text that is similar to the text produced by humans. What I would like to convey through this presentation is what these innovations really mean. And in order to explain that, I want to give you a wider picture of what has happened. And I would like to start by talking about the way that science approaches a machine learning problem, like in our case, and here you can see the recognition of image. The way that we approach the problem is the following. First of all, we collect data. That pertain to the mental capacity that we want to simulate. Then we use a mathematical model in order to ensure the good functioning of this model based on this data. And then if we are satisfied, we implement this model in practice. Science has an obsession with what is called benchmark data, that is reference data, benchmark data, which is collected very carefully because this data is perceived as a representative data of the problem that we are trying to resolve. And of course, many risks are involved in this endeavor, and I would like to touch upon these risks. Continuing with image recognition, I would like to say a few words about the fact that computers have beat humans when it comes to image recognition. Here you can see the picture of a man who is the director of artificial intelligence in Tesla. And he focuses on the self-driving cars. So when he was a student in Stanford University, studied a great volume of images, and he tested himself on how he's able, in order to see whether he was able to recognize the content of these images. And he measured the precision he got. That was 95%. So the error he made was 55%. In 5% he was wrong. In 95% of the cases, he correctly recognized the content of the images. So Andrei realized that between 2014 and 2015, the best algorithms started being more precise compared to him. And it was at that point that science decided that computers had beat man when it comes to image recognition. However, what does it really mean that algorithms beat Andrei Karpov in this specific task? I claim that it doesn't mean a lot. And we have actually started to see that very clearly. First of all, if you get the same algorithms that have beat Andrei Karpathy with this data and you try them out with other groups of images but with different brightness, with different orientation of the objects represented in the image, you will see that this 95 precision drops by 50%. So we have this reference point that we have resolved, but then we get another sum of images as reference, and we see that there are problems that we haven't solved. Some other ways that prove that technology fails. Here you can see a Tesla car crashing on a truck that it has stopped at the left side of a highway. Top right, you can see a robot that cannot even walk, maybe because the terrain on which it was called to walk is different to the one that he was used to. Bottom left, you can see a comparison of what gives an image recognition algorithm when the content included in the image has the right orientation, and indeed the response is correct. Here it says revolver, for example. Here it says vulture. But when we change the orientation of the object, then the algorithm responds that this image depicts a mouse trap and that this image represents an orangutan. So you can see that the slight change of orientation changed the response of the algorithm. And bottom right, you can see a small turtle that they actually printed in a 3D printer, some MIT students a few years ago. Then they painted the shell of the turtle, and the result was that even the best algorithm could not give the correct answer. Actually, the answer given was that this was a rifle and not a turtle. So this proves that algorithms fail. However, problems do not stop here. A few years ago, an article that was published in the ProPublica magazine sounded the alarm for the bias that the algorithms can have. As you probably know, AI algorithms are being used in the judicial system of the United States for the imprisonment of crime suspects, and it has been proven that these algorithms are very biased when it comes to people that have certain features. Here we have two suspects. One of these suspects has done far more crimes compared to the second one, but the second one, because of the color of his skin, is considered to be far more dangerous. Moreover, it has been proven that although algorithms can beat humans when it comes to very difficult games, like poker and the one that you can see on the slide, people can take advantage, can actually use algorithms. Here on the left, you can see a self-driving car that tries to take its place in the highway, but the other cars do not leave space for it. The car cannot change lanes, and the decision it makes is to leave the highway and then try again. So we can see that this is something that all of us drivers can easily and quickly resolve in the highway. In other words, it is a game that we can play very well and very effectively. A game in which artificial intelligence fails. And on the left, we can see a game that very few of us can play well. And it is a game where artificial intelligence can actually play very well and beat us. Now, you will ask me, why is this the case? How can algorithms resolve very difficult games and cannot resolve easier games? The reason is that the games on the left have very specific rules and a very specific reference framework, whereas the games on the right, although simpler, have various different parameters, conditions that change, and this is something that cannot be resolved by artificial intelligence. Artificial intelligence cannot quickly adjust to new circumstances. So to summarize what I said in the beginning of my presentation, why does AI fail? There are many things that need to be done in order to reach the point where artificial intelligence is reliable. The point is that our technology is not reliable enough when it comes to incomplete data that are interdependent, or when it comes to reference frameworks that may change. Another important aspect, and maybe we can talk about that during the discussion, is that although artificial intelligence has greatly focused on its capacity to make forecasts, it hasn't progressed enough in order to identify the causality of its observations. And many of us know that the discovery of causality of our observations lies in the heart of what we understand. Artificial intelligence is not in the position to compete with other machines or with other human players, and it cannot even cooperate with other machines or other players. Some other points, which are a little bit more technical but equally important, are the following. We don't have the same access to the developments made in the scientific sector. We don't have the same access to the hardware and to the computational capacity that is needed in order to develop artificial intelligence applications. Not all of us have taken the necessary measures so that artificial intelligence and its use continues to be biased, and the domain hasn't evolved in such a way as to make the most of the progress made in other disciplines, a progress which could actually allow us to combine and synthesize better AI systems that would take into account all this progress made in other cognitive fields. Now, these were some of the very important problems that technology faces today. And in the second part of my presentation, I would like to focus on some of these that are a bit technical. And I would like to talk about the lack of reliability of artificial intelligence, lack of robustness, if you like. And this takes me to the second slide I showed you that shows the way in which scientists develop AI systems. When we developed AI systems, we had to select data that was relevant to the application we wanted to develop. To collect representative data for the mental capacity that you want to resolve is a very, very difficult problem. Representative data can only be collected in a laboratory. It is very difficult for someone to collect representative data, training data, outside a laboratory. And now allow me to talk about 3 ways in which training data fails to be collected. I will talk about these 3 ways by showing you another example in which AI fails, and this has to do with the algorithmic hiring. As you may know, there are now many companies that check the CVs, or ask you questions, or ask you to resolve some puzzles, or to upload a video of yourself. And based on certain criteria, they decide if you are a good candidate for the position. By using this example, I want to show you 3 ways in which AI fails in that respect. And this will allow me to shed some light on some broader issues. The first failure mode is related to incomplete data. And coming to the example of the algorithmic hiring, I would like to say that obviously the data that we have at our disposal are incomplete because this data is collected by a company under specific circumstances. And since the society or the company has certain stereotypes, it is obvious that the data that will be collected by them will be based on these stereotypes. To be more clear, obviously the data that I will get from the real world will include more male software engineers and more women teachers, for example. This does not mean necessarily that men are better than women when it comes to software development, but the truth is that if we collect data from the real world, we will get this type of data. If we use this data to develop the algorithm, it is obvious that the algorithm will use this stereotypical data, this biased data. As I was saying earlier, incomplete data can result because of various different reasons when you are outside the laboratory. The first reason was the one I just mentioned, that our society is by nature biased, which means that we cannot get all the data that we could get in a different circumstance. Second failure mode. We designed the experiment in the wrong way. We collected the data in the wrong way and we collected biased data. Moreover, incomplete data stems from the instruments that we use. Maybe the instruments are not reliable and maybe we are making wrong calculations and measurements. Moreover, incomplete data can also be the result of our inability to use all available data. And the question is, what do we do when we have incomplete data and will continue to be incomplete for all the reasons I've mentioned before? What can we do about that? The problem is very important because if you train an algorithm by using incomplete data, then there is no doubt that the forecast that it will make will be biased, and there is no doubt that these predictions will reproduce the stereotypes. What can we do about that? Obviously, this is a challenge that has concerned all the scientists, except the computer science scientists, all the statisticians, for example, all the experts on surveys are concerned with that. So what can we do from a mathematical point of view? Since this is a science festival, I would like to present to you a theorem. As you remember that I showed you some images. We used some of the objects depicted in order to create a bigger image. So, train AI by using incomplete data is something similar to that, which means that out of an entire population, which is here represented in blue, you actually observe only part of the population, a subpopulation, and by doing that, you want to understand how you can expand beyond the context from which you got the data. There are different ways you can do that. You can write your name, for example, where you haven't made any observations. So the question is, how can you expand that beyond the context where you made the observations. How you can extrapolate. For us, extrapolation, computer software scientists, extrapolation is equal to blasphemy. For statisticians, this is also true. So the question is, how can you resolve this problem? A theorem that we presented recently is based on the following, that you can do that in different dimensions as long as the phenomenon that you are trying to understand is governed by anti-concentration of measure, of mass, better. Many of us are not very familiar with what happens at different dimensions, but one of the things that happens is that here we have orange presented in 3D. The juice of the orange is concentrated in the center of the orange. A multidimensional orange actually pushes the juice towards the skin. This is what's happening when we have different dimensions. So the question is, has the juice reached the skin? Is it very close to the skin? If it has reached the skin, then you cannot make the intervention you want to make. Is it very concentrated? Is it anti-concentrated? Then you can actually intervene. Coming back to the algorithmic hiring, I would like to talk about a different way that AI fails. And this second way has nothing to do with incomplete data, but with the fact that the way that I perform at my work does not depend exclusively on me. It also depends on the social framework that I will be introduced. In other words, even the definition of the problem that we are using in AI, according to which a prediction algorithm that assesses the performance of the employee should not be based only on the features of the candidate himself, but also the context that this employee will be introduced. So we can see that the approach to the problem is the wrong one. And in order to make a prediction, you need to take into account the framework, the context in which a person will be introduced. Me, for example, can do excellent work in MIT, but very bad work, or not so good, in a different university. And maybe this happens because MIT allows me to do excellent research, whereas another university does not allow me to do that, does not give me with everything I need. So when you have an algorithm that assesses my performance at work, you understand that this is wrong, since the definition of the problem is not accurately given. We're not units, we are parts of a whole. We are parts of a societal whole. And the extent that we will progress is also related to the context in which we are placed. Of course, this is well known to social sciences. Many behaviors have a social character, social nature. And of course, everything I'm saying relates to statistical physics, which tries to examine how minute interactions influence the wider context and how the wider context influences these minute interactions. From a technical point of view, we do not have the instruments or the tools to have machine learning when there are such interdependencies. In order to achieve that, we need to use tools of statistical physics, tools that we haven't actually incorporated in the AI field. And this is a field in which me and my students are working. The third and last way in which AI fails has to do with the strategic manipulation of data. And going back to my example of algorithmic hiring, I would like to tell you that there are some statistical phenomena that the algorithm needs to take into account. For example, if I know that your company uses a specific algorithm to evaluate my CV, then obviously I will try to change the features in the CV so that I can manipulate the results given by the algorithm. So if your algorithm does not take into account the strategic behavior that I will have in order to manipulate your algorithm, then the forecast of your algorithm will also be wrong. So that's all I had to say in brief. And to conclude, I would like to say that AI has made lots of progress in the past decade. Great innovation, and this innovation has now become part of our life. Maybe we haven't realized that yet, but we will realize that in the future. However, I would like to say that there is a risk that we need to take account. These algorithms may perform well in a laboratory, but they do not work as well outside lab conditions. The deployment of these technologies in the real world requires a lot more robustness and reliability of these technologies. And in order to do that, we need to place our attention on different things, like the ones I mentioned, like the biased data, the dependencies between data, and with the strategic manipulation of data. But also we need to check very many other different things like causality. We are working on that, but we will require a whole spectrum of cognitive fields in order to deal with this issue. And that is why I would like to invite all of you to take part in this endeavor. Thank you very much.
Thank you, Konstantinos. A rather interesting presentation, and I'm glad that you gave us an optimistic message. Even though progress is far away, AI is exceptional. So we would like to invite people who want to make research in the field. Something
Το AI είναι στη καθημερινότητα.
I want to discuss is that AI is part of our daily lives. Email is an example. In spam folder, we see the spam messages. Even for that, there are algorithms that do a classification why an email is a spam or not a spam. Things that we use daily that come from AI or phonetic recognition. We talk to our devices to turn on the lights, etc. I have some questions from the audience and from me. You mentioned that the quality of models depends on the quality of data. Let's take a step back and see how machine learning started, how the data science evolved, and we started learning from data. Tell us a couple of things there. First of all, AI has a long background, and statistics might be the basis of that. Statistics actually processes a collection of data, and from this process, it proceeds with predictions or tries to find causalities. AI starts back in the 1950s in MIT and Dartmouth and sets as its objective to use statistics and developments in computer sciences back then in order to solve issues by reproducing mental processes, human mental processes. When you try to do something that grand, you have to determine the problem and put it in framework so as to be able to measure progress. You cannot start by saying that I won't use biology to build a mind. Instead, you might say, I will build a robotic hand that can lift a glass. Something very simple. But this should not become the rule. To always, in other words, look intelligence in a framework and just solve a problem here or there or somewhere else. Because if you focus on specific problems, you miss the substance of what makes our mind exceptional. Because our mind can adjust empathy developed in an object and implemented in another object. If I teach a robotic hand to do that, to lift a glass, and then I wanted to teach to lift a plate, I need to retrain it, something that our mind does not need. That is what we miss when we focus on specific problems. Coming back to your question, a part of AI has to do with statistics and data science. Another part has to do with calculations, how these things happen in a computing system with all other abilities that can be offered by a computer system, or like the use of multidimensional optimization of multidimensional models. I'm glad that you mentioned computing because we have an interesting question. Congratulations on the presentation. From Moravec's paradox, we know that reasoning needs a small computing capacity. And where do we stand today? Does this paradox still exist in AI? The paradox should be seen from a philosophical point of view. Technically speaking, in order to answer that, we need to have a definition of the problem we try to solve. In any case, decision making is not an easy problem to solve. Even decision making is a multidimensional problem that needs computing capacity. So the problem is not defined mathematically, so we need, in order to solve it, to observe human beings. How can we mathematically approach the issue one way or another? If we have a mathematic approach, this approach will be rather complex and need computing capacity.
Πάτε μου αυτό το παράδοξο ακόμη και σήμερα, βεβαίως. Υπάρχουν πάρα πολλές ερωτήσεις για σένα, Κωνσταντίνα.
There are a lot of questions for you, Konstantinos. I work in AI for many years now. And what we do in companies is to have this test Turing, to build a system that will fool us and make us believe that it's not a system. Since I work with voice recognition, it is interesting on how we change voice. How far are we to reach test Turing? And talking about failures, give us an optimistic point of view. I want your point of view here. Test of Turing test is an interesting test that doesn't touch upon the substance of AI. And an example is what we can see in social media, in that you can communicate either with men or with people or robots, and since there are answers given by both, you cannot actually be sure on whether you communicate with a robot or with a human being.
Περάσει το Turing test, αλλά δεν είναι όλη η εικόνα του τι θα πει πραγματική νοημοσύνη.
So this is what is the approach. Somebody asks us, what is your thoughts on chatbots in the Greek educational system? A wider answer: the use of chatbox technologies or AI technologies in educational system is important, and the reason is that they can help us in having a personalized education. In other words, where I would need, it is a sector, but it is a wider topic. Sector AI can be used is to decide which notions or tools or elements are not understood by students properly, and focus on training him in these things that he lacks. When I have a test, in order to be able to give wrong answers to questions 1, 3, and 5, I am not well in a specific chapter of algebra, so I need to be trained in linear algebra in order to be able to answer these questions. This is a simple way that technology can be used. I need to suggest something else, a wider challenge. When I was a student, what bothered me was that being a student at school, I had always the feeling that I am in an educational lab that will help me go out in the real world in 20 years. I was a passive observer of society. I received the knowledge, but I didn't know how it will be implemented, and I knew that in 20 years I will go out in the real world and use some of the knowledge I gained at school. That was my feeling when I was back at school. I think that schools should be co-participants in society. Co-participants in what is happening around. And the tools that we have at hand, programming, AI, and obviously the rest of the subjects can be used by students in order to have a result, to participate in the society, to solve issues that bother societies. That is my wider approach. Schools should have participation in society. That is what will help students. I like that. And now that I've been in the United States for years now, well, here in the United States, the teachers don't teach how to solve the answer, but the problems are shared among students in order to solve them. And at the end, teachers come and give them alternatives. And what about the research center in AI in which you work in Greece? Tell us about the opportunities. I am rather enthusiastic that I've read about that. First of all, I need to say that it is an innovation center and research center in AI, the objective of which is to cooperate with scientists in universities, Greek universities, students and professors, and involve people from the Greek diaspora and people that are very strong in this field, and we want to bring them back and empower Greece. Well, this center is underway. I cooperate with other two exceptional scientists, Mr. Papadimitriou, my mentor in Berkeley, and a professor of mine from the Technical University of Athens, and it is under the auspices of 2021 committee. It is one of the projects undertaken by this committee. We don't know if it will eventually happen. We need to have assistance from various private entities and agencies. We hope that it will eventually be realized and will help research in Greece. The scientific will help at scientific level and business innovation level. And it will help convey the outcomes in the society, to the society. Wow, that's exceptional. And I think, and I speak on behalf of Greeks, where can we learn more about that? If you can wait for a couple of months, we will be able to tell you if this center will be realized eventually or not. Thank you very much, Konstantinos. Congratulations on your presentation. I have a lot of questions about AI and data and how to solve problems. Your presentation has given fruit for thought. You will get a lot of emails, I'm sure. Thank you very much personally and on behalf of Athens Science Festival for your speech and time. Thank you very much. Bye. Bye.